Hey guys! In the previous video lesson of sinusoidal functions, we learned how to draw the graphs of parent sine and parent cosine function. In this video lesson, we'll be talking about the transformations introduced on the parent sine and cosine functions and how that would affect their graphs. In order to understand transformations, let's first understand what is the general transformation equation. The general transformation function equation for parent sine can be written as y is equal to a sine k x minus d plus c. Similarly, general transformation equation for parent cosine function can be written as a cos k x minus d plus c. A, k, d and c, they all have same meanings no matter what is your parent function. So a, as you know from the introductions to function unit, a represents as vertical stretch or vertical compression, whereas in sinusoidal functions a has another meaning and that gives you your amplitude. K, from introduction to functions unit, you know, gives you horizontal stretch or horizontal compression, whereas in sinusoidal functions k is going to determine your time period. And in order to use k to find out your time period, the formula is 360 divided by k value. D, you know from your previous knowledge, represents horizontal translation. In sinusoidal functions, it also represents phase shift. C, again from the previous knowledge you know, represents vertical translation. And in sinusoidal functions, it is going to be used to determine your equation of axes. So C gives your equation of axes value. Apart from this, you have to also remember that if A value is negative, there is a reflection over x-axis, and if k is negative, there is a reflection over y-axis. As we now know the general rules of transformations, let's do an example in order to understand it better. Let's take up the first question as y is equal to -2 cosine 3 x minus 20 plus 1. If we are asked to determine the amplitude, time period, phase shift, and equation of axes, all we have to do is just know our a, k, d, and c values. Whenever you're given an equation, you always write on your a, k, d separately. So your a is this, -2, k is this, that is 3, d is this, that is 20 degrees, and c is this, that is 1. As we know, a represents the amplitude. What is the meaning of amplitude? You can watch my previous video of interpreting sinusoidal functions that explains you all the meanings of these terms. As the a value is -2, my amplitude is only the magnitude of a, and that is number 2. Negative sign just represents the graph is reflected over x-axis. So we will write that meaning separately. Next we have is time period. In order to find out time period, we will use k value, and the formula is 360 divided by k. K is 3, so that gives us 120 degrees. Next is phase shift. Phase shift is another name of horizontal translation. Since this is a positive 20 degrees, we would just say that the graph is shifted 20 degrees right. Equation of axes is represented with c value, and because it's an equation, it's written as y is equal to 1. Let's take up another example. If we have y is equal to sine 3x minus 30 plus 2. Now always remember that we have to match the given transformed equation with the general transformed equation. Since the sine general transformed equation is a sine k x minus d plus c, now we would see what is a given to us. As a is not given to us as anything, we can put it as 1. And then when we look at our general equation, we just see that k is factored out of x minus d. K is anything that is multiplied or divided with x, but in this case, Your k is not factored out. So that is our first step. We have to factor k out and we have to rewrite this equation as y equal to 1 sine. If we factor k out, my k value is 3. I'm going to factor 3 out. I divide 3x by 3, I get an x. I divide minus 30 by 3, I get a negative 10. And then this is plus 2. Now this equation looks exactly like this. That is my parent equation, parent transformed equation. So I can read my a as 1. That is, my amplitude for this equation will be equal to 1. As my k is 3, I can use my k to find out my time period. And this is 360 divided by 3, which is 120 degrees. I can see my d is 10 degrees. I always match my equation to my parent function, and my parent has a negative sign here. Here also it's a negative sign, so my d is just this value. So d is 10 degrees. No sign means my phase shift is right. So I will write down my phase shift as 10 degrees right. Next is I have a c value, which is 2. So as I know, c gives me my equation of axes. So I would write on my equation of axes as my y is equal to 2. Just for the sake of practice, let's do another example. If my question is given as y is equal to negative 3 sine 5x plus 1. First step is always write on your general transformed equation. For sine, it's going to be a sine k x minus d plus c. We notice that we are given the a value. We are given the k value because k is anything that gets multiplied or divided with x. So we're given that. We're not given anything in a bracket. That means we are missing a d here. But we are given this number. That means we are given a c value. Now, if I want to rewrite this in order to match it to this equation, I can rewrite it as y equal to negative 3 sine. In the bracket, I can put in k outside as 5, x minus 0 because I'm not given anything as d. Always remember, if your d and c, always remember, if your d or c is not given, you put it as a 0. If your a or k is not given, you put it as a 1. Now I can write down my amplitude as 3 because a is negative. So I can write down that this graph is reflected over x-axis. Next we have is k given to us as 5. That can help us find the time period. So time period is 360 by k, which is 360 by 5. When we divide it, we would see it gives us 72 degrees. So my time period is going to be 72. There is no phase shift as the d value is 0. The equation of axis is y equal to 1.